Good day, class! Our lesson for today is all about counting the number of occurrences of an outcome in an experiment. At the end of this lesson, you are expected to first determine the number of sample space in an experiment using table, tree diagram, and systematic listing. Second, use fundamental counting principle to count the outcome. And last, apply it in a real-life situation. You have learned the basic concepts of probability in the previous lesson. As you go through this lesson, it will help you to determine the number of the sample space of an experiment using different methods. It is important to determine the number of the possible outcomes of an experiment to easily visualize the choices that we have. A sample space or probability space is the set of all possible outcomes of an experiment. There are different methods to count the number of possible outcomes of an experiment. We have the using a table, using a tree diagram, and using a systematic listing. If we use a table, it is one method to determine the number of possible outcomes of an experiment is by creating a table or chart. This method is commonly used for two events. If we use tree diagram, it is the useful method to easily enumerate all the possible outcomes using the line segment as the branch from starting point to outcome point. And if we use systematic listing, it is another method to count the number of the sample space of an experiment is by listing down all the possible outcomes in systematic way. So, to easily understand, let's have an example. Green Cub's Pizza Parlor offers 3 kinds of toppings and 4 kinds of crust. How many pizza choices with 1 kind of toppings and 1 kind of crust can be made in Green Cub's Pizza Parlor? So for this example, let's use first the table. So if we make a table, since we have 3 kinds of toppings and 4 kinds of crust, it's up to you, class, if how many it depends on you if where do you put the given, like crust and topping. So for this example, we are going to put the crust for our rows. So since we have 4 kinds of crust, so we can make 4 rows. And since we have 3 kinds of toppings, it represents now the 3 columns. So again, to easily understand the use of table, for the 3 columns, it represents the 3 kinds of toppings, which are the ham, pepperoni, and veggie. And for the crust, we have 4 kinds of crust, which are classic, pan, thin, and stuffed. Now, to know how many pizza choices with 1 kind of toppings and 1 kind of crust can be made in Green Cub's Pizza Parlor, let's fill now the row in this table. So for example, if we have a crust classic or classic crust and a toppings with ham, we will have now ham and ham classic. Next, if we had pan crust and our toppings is ham, we will have ham pan or ham and pan. If we have a crust which is thin or thin crust and our toppings is ham, we will have ham and thin. Next, if our crust is stuffed and our toppings is ham, we will have ham and stuffed. We already complete now our first column. Next, for our second column, if our crust is classic and our topping is pepperoni, we will have now pepperoni classic. Next, if our crust is pan and our topping is pepperoni, we have pepperoni and pan. Next, if our crust is thin and our topping is pepperoni, we have now pepperoni and thin crust. Next, if our crust is stuffed and our topping is pepperoni, we will have now pepperoni and stuffed crust. So now as you can see, we already fill now our second column. Next, for our third column, which is our veggie, if our crust is classic and our topping is veggie, we have now veggie classic. If our crust is pan and our toppings is veggie, we will have now veggie and pan crust. Next, if our crust is thin and our topping is veggie, we have now veggie and thin crust. Next, for the last, if our crust is stuffed and our topping is veggie, we will have now veggie and stuffed. Now, to answer the question which is how many pizza choices with one kind of toppings and one kind of crust can be made in Green Cub's Pizza Parlor, let's count the results. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So for our answer, there are 12 possible one-topping pizza choices in Green Cub's Pizza Parlor. So now, if you don't satisfy to use the table, we can use another way or the another method, which is tree diagram. So in tree diagram, it is look like this. Let's make a tree lines represent our toppings, which are ham, pepperoni, and veggies. But it's up to you, class, which among the two given are you going to write first. Either it is crust or toppings. So if you want to write first, or if you want to put first the crust, you need to make 4 lines. Since in this example, I want to use the toppings, since toppings have 3 kinds, so I want to use first 3 lines represent our 3 toppings. Next, we all know that in crust, we have 4 kinds of crust. So in each topping, let's make 4 lines from our toppings. And that 4 lines in each topping represent the crust. We have the classic pan, thin and stuffed, classic pan, thin and stuffed, and classic pan, thin and stuffed. So now after this, we will have now our choices. So let's write now our choices. If we have ham, if we have a toppings which is ham and a crust is classic, we will have now ham and classic. If the toppings is ham and the crust is pan, we have ham and pan. If our toppings is ham and the crust is thin, we have ham and thin crust. If our toppings is ham and our crust is stuffed, we have ham and stuffed. Next, if our toppings is pepperoni and our crust is classic, we have pepperoni classic. If our toppings is pepperoni and our crust is pan, we have pepperoni and pan. Next, if our toppings is pepperoni and our crust is thin, we have pepperoni and thin crust. Next, if our toppings is pepperoni and our crust is stuffed, we have pepperoni stuffed. Next, for our last toppings, if our toppings is veggie and the crust is classic, we have veggie classic crust. Next, if our toppings is veggie and our crust is pan, we have veggie and pan crust. If our toppings is veggie and our crust is thin, we have veggie thin crust. And if our toppings is veggie and our crust is stuffed, we have veggie stuffed crust. Now, as you can see, how many choices do we have? Like in using a table, we have 12 choices in this tree diagram. like in using a table, we have 12 possible results or 12 possible choices. So it's up to you if what type of method do you want to use. Either it is using a table or tree diagram. So after this, let's use also the systematic listing. So in this, by counting the line segments pointing at the choices, there are 12 possible one-topping pizza choices in Green Cub's Pizza Parlor. Now, if you don't like to use the tree diagram, you can use the last method, which is the systematic listing. In this method, you just list the choices. Given the choices, which are the 3 kinds of toppings and the 4 kinds of crust, you just list the following choices. Like, for example, we have ham classic, ham and pan, ham and tin, ham and stuffed. Pepperoni classic, pepperoni pan, pepperoni tin, pepperoni stuffed. Veggie classic, veggie pan, veggie tin, and veggie stuffed. Now, as you can see, in systematic listing, it is easy to use compared to tree diagram, because you just need to list the given to find the possible outcomes. So now, for our answer in this, it's the same like table. It's the same if we use the method of a table and tree diagram. So again, we have in Green Cub's Pizza Parlor can offer 12 different one-topping pizza choices. Now, let's take up another example. Maria was invited to attend her friend's birthday party. She has 3 shirts, which are yellow, white, and black, and 2 pairs of pants, which are jeans and slacks. However, she cannot decide what to wear. Let us help Maria to decide what she will wear for her friend's birthday party. Now, let's use first the first method, which is using a table. So for this, I use 3 rows represents for the 3 shirts and 2 columns represents for the 2 pants. So for our shirts, we have yellow shirt, white shirt, and black shirt. And for the 2 columns, it represents the 2 pants, which are the jeans and slacks. So now let's fill now the table. So for the first column, if we have yellow shirt and jeans pants, we have yellow shirt, jeans. If we have white shirt and jean pants, we have white shirt and jeans. Next, if we have black shirt and jean pants, we have black shirt and jeans. So now, we already fill out the first column. Next, let's proceed to the second column. So if we have yellow shirt and slack pants, we have yellow shirt and slacks. Next, if we have white shirt and slack pants, we have white shirt slacks. Next, if we have black shirt and slack pants, we have black shirt slacks. Now, the answer based on the question, which is how many pairs or how many outfits can Maria wear to attend her friend's birthday party? So Maria can wear 6 different outfits to attend her friend's birthday party. Again, these are the yellow shirt jeans, white shirt jeans, black shirt jeans, yellow shirt slack, white shirt slack, and black shirt slack. So as you notice, class, we can apply this in a real life situation. Now, after using a table, if you're not satisfied to use this method, you can use the tree diagram. So I will make 3 lines represent the shirt. So we have yellow shirt or the YC for the code, if you want to write a code, white shirt or WC, and black shirt or BC as our code. Next, in each shirt, we can use or we can choose two pants, which are the jeans and slacks, and jeans and slacks. So for the outfits, if our shirt is yellow and the pants is jeans, we have YCJ, or the yellow shirt and jeans. If the shirt is yellow and the pants is slacks, we have WCS, or the yellow shirt and slacks. Next, if the shirt is white shirt and the pants is jeans, we have WCJ, or W shirt and jeans. Again, we just writing the code so that we can easily write the possible outcomes. Next, if we have white shirt and our pants is slacks, we have WCS. It's represent as the W shirt and slacks. Next, if we have black shirt and jeans pants, we have BCJ, or the black shirt and jeans. And if we have black shirt and slacks, we will have BCS, or the black shirt and slacks. So as you can see, we have the same answer using a table. So again, Maria can wear 6 different outfits to attend her friend's birthday party. So now, if you're not satisfied to use tree diagram, let's use the very easy method, which is the systematic listing. Again, in systematic listing, we just write the outcomes. So we have yellow shirt jeans, white shirt jeans, and black shirt jeans. We have yellow shirt slack, white shirt slacks, and black shirt slacks. Again, the answer for this is Maria can wear 6 different outfits to attend her friend's birthday party. So I hope class you understand our lesson for today, which is the counting the number of occurrences of an outcome in an experiment. Thank you for watching.